coming back with another banger, teaching Miss Jensen some calculus that she already knows that she's teaching me. Because you know she's a W teacher. Alright, so 1.15, limits at infinity in horizontal asymptotes. So horizontal asymptotes. Basic rules for horizontal asymptotes, I think it's a good place to start. So when the denominator grows faster, which means the denominator is a bigger number than the top one, equals 0. If the numerator and the denominator grow equally fast, so they're both a big number, not the same, it equals 1. But if the numerator grows faster than the denominator, when you have a big number over a not as big number, it equals infinity. So first, let's recognize here how fast these are growing, and we're going to rank them. Now, you can see is here is f to the power of x, then f, then to a huge spike, to another huge spike to super duper big. Not even, it's too big to even be on the paper, I guess. Then we know here, so it goes e to the x to 2.7, 22,000, and then it jumps really big, and then to a really big number. So we know that is number 2. We keep going down the list. I don't want to waste all the time on those because I would like to get to some of these at the bottom here. So we're trying to find the horizontal asymptotes of each function. So look at -4. We're looking for what? We're looking for the top and bottom. We know that the top is growing faster, x squared, and there's 3x. And we know that will grow faster. So we know that there's no horizontal asymptote. It is continuous. There's no horizontal asymptote when the numerator grows faster. Now, when they are the same, we put, and then it's 1 over 3. We know that the horizontal asymptote will be 1 over 3. When they are the same, we just take the values multiplied by the x. Now, when the bottom is bigger, 3x squared over and then x, we know that the horizontal asymptote would just be 0. And look in here. They will actually be the same here when you multiply it out. You will get 4x squared, and you will get x squared. I'm sorry, you will get 16x squared and x squared. So you'll get x squared over 16x squared. And you know, you just put the top over the bottom, and you get 1/16 is the horizontal asymptote. Now, for me on this one, it's axis from infinity from the left to the right because, and only because, of the square root. You get positive and negative values. So you get 2x, you have 2x over 3x. They're the same, equally, the x and x are the same, they grow equally as fast. So you'd put 2 over 3. But because you square rooted it, you also have to put negative 2 over 3. And the same thing goes here. Now, I would like to do this one. So 1 over x, we know when the bottom grows faster, it is 0. So we get the limit of -4e to the 0 power. We know that e to the 0 is just 1. Anything to the 0 power is just 1. So then you get -4 times 1, which is -4. So it can also be applied to limits.